Let us see today single layer perceptron. Good morning, friends. As this is a very important topic in the machine learning, let us see what is the single layer perceptron. Through the PPT, let us look at first. Okay. So the perceptron is a single processing unit of any neural network, and Frank Rosenblatt first proposed in the year 1958, right? So normally in biology, you have learned about the simple neuron, right? So in which the perceptron is like a linear classifier and which is used in the supervised learning, right? So normally we will use the linear classifier in the supervised learning. Let us see with the biological diagrammatic representation of the neuron in which you have dendrite as an input, okay, to the neuron which will be given, and cell body is the another part. We can have it is like a processing, right? Processing will be happening here, and you will have the axon that will be considered as like a output. So in the same way, when we see about the neural network, you will have the input layer, and you will have like a processing layer, and then you will have the output layer. So when you see here in a single layer perceptron, you will have only one layer, right? Input layer, and then middle processing, and then finally output layer, right? So that's why we can say it is a single layer perceptron. Coming to the multiple layer means you will have like many hidden layers. So that is how we will see the difference. So we have compared with the biological terms like dendrite, cell body, and axon, in which we can say input and then processing and then output. That output will be connected with many neurons in the biological term, right? Okay, so when you see the simplified neural network, so these are x1 up to xn. Okay, so that is you can see all these things are considered as like an input, and which will be united with the weights, and then we will go for the summation of bias. That is every weight which we are adding with the input layer have to be multiplied and make a summation of it, and then we have to add bias into it. Okay, so how you will go for this activation when we are just finding the value of, when you finding the value of w and x, multiplying it and then plus bias, if the value which is greater than equal to 0, so that is the time it will be more active. So it will be considered as 1, right? And when this value of w x plus bias, which value which is less than 0, means we can say it is non-active, that is a 0. Got it? So this is how we are just making the activation function for the different inputs which will be connected with including with the weights and with the bias. Okay, we are just adding the constant value of bias into the weighted input layer. We are checking the value which is greater than equal to 0 or less than 0. Based upon that, we can say it is active or inactive, right? Okay, and that gives the output. Okay, so this is the simplified neural network. And when you just show the difference between the single layer and multiple layer, you can see here input layer. Okay, so only one input. Okay, and then we are having the input layer in which multiple inputs which we are giving, which will be added with the weights, and you will have only one output layer. Got it? But here you can see many output layers and also many hidden layers, okay, between the input and the output. So that is the difference between the single layer and multiple layer perceptron. Okay, so we can see some more difference between the single layer and multiple layer. You can see about the architecture, it is like only one layer of neurons. Okay, but here you will have multiple layers, and complexity, when you talk about it, is simple, as it is not much complex in okay, diagrammatic representation. You can see only one input layer, and you will have like process, and then you will have one output layer, right? And but here we can see the complexity is having the multiple layer and connection, so we can say that is complex, right? And then learning capability, that you can say it as like it is a linear separable and it is a classification. Okay, but here both linearly and non-linear separable function. When we see here linear separable, simply and or okay between the two inputs. But here and all we have to go for complex, that is XOR. Okay, so that is how you can just differentiate the SLP and MLP. Okay, and also we can see that the classification. Okay, task. That is a binary classification task example, simple logic gates. Okay, but here you can go for image recognition, NLP, deep learning applications. Likewise, you can go for the complex architecture. Okay, so that is how you can see the difference. Okay, so the next is we can see between the NLP and this one. Okay, we have seen the difference. So that is how we can see the difference between the NLP and uh, SLP. Okay. So when you see the activation function, you can see here for the okay, SLP, you can see that you are using the threshold. Okay, so that is either 0 or 1. That's all, right? We have seen about the condition. Okay, if it is a 0, which is greater than the x, or if x which is greater than equal to 0, right? So the mainly we can see the function definition, either it will be 0 or 1. We are just checking with the threshold. Okay, but when we go for MLP and all, we will use the terms like sigmoid, rectifier, hyperbolic tangent, and we are using the complex architecture. Okay, so to show the to find out the activation function, right? In SLP and MLP. Normally, in our syllabus, we are having only SLP, but you should know the difference, okay, with the MLP as well, right? Okay, and this is how we are just finding the learning process in the neural network. So as we know, these are the input layer and these are the weights which are added with the input layer. And we are getting the summation of the weighted input layer. Okay, and then we are predicting the output value, that is y cap, right? Okay, so we have the actual value also, y, and that is the actual value, and this is the predicted value. When we make the subtraction of it, we will find the error, right? We can easily find out the error, right? So that is how we are calculating the error, that is computation of cost, right? So that we can say it as like y cap minus y the whole square, 1 by 2 into, right? So that is how we are finding the error rate between the predicted and the actual value, right? Okay, so when we see here, you can see that weight, we are just passing it into for updating the weight. Okay, for updating the weight, you can see, right? Okay, so once if we calculate here, we are updating with the weight W1, W2, and W3. Okay, according to the value what we receive, whether if it is a predicted one or the actual one, right? According to that, we have to update the weights. Okay, so when you see in MLP and all, okay, so you can see that if you are having a multiple input, okay, multiple input, each and every row value we can consider as like an different input, that is x1, x2, x3. First, x1 will be considered as a study hours, and then x2 will be considered as a sleep hours, and then okay, quiz, that is another one input value we can take it. Okay, so all these things we can take it as like an input value, right? And then we are just multiplying with the weights. Okay, and then doing the summation of it. Okay, and then finding the results. Okay, that is y cap. Actual value we have, just to make the subtraction of it and finding the error. Okay, so this is how when we go for the multiple. okay, columns, that is the time how we are going to deal with. Similarly, here also, row IDs, study hours, sleep hours, quiz, okay, and so on, and how we are going to find out. Okay, so here we can see that in this table you have 8 different rows. Okay, so 8 different rows, and each and every row we will have a separate perceptron. Okay, so that's why we have seen 8 rows. So 8 different perceptron. Okay, we have to make. Okay, in order to show what are the weights we are going to assign, and then what is the input layer. Okay, and then finally we find the activation function, right? Okay, so that is how the process continues for each and every rows. Okay, so that is the main thing you should always remember. Okay, and how the weight which will be updated. Okay, so you can see the weight new, which is equal to weight old. Already what weight which is present, that have to be added. Along with that, we have to do the alpha. Okay, into D into Xi. Okay, all the input layers. Okay, so that is how we are just finding out for the new weight updation. Okay, so weight updation, new weight. Okay, so new weight. This is how we are just finding out. When you look at here, you can see what is the difference here. Okay, so when you take the first row, okay, so attribute 0 and weight 0. Okay, so automatically when we are just making the multiplication of it, you will get the 0 only. Attribute 2 and weight 2, when you are multiplying, that also we are getting the 0. Okay, so when we just subtracting the value of this, you will get the output as 0 only. Okay, so this is how it is predicted as 0. So difference which is gives the 0, and learning rate is 0.5, that is the given data. Okay, and this is how we are going to update for all the difference. Okay, all the difference, and we are going to add the bias to it. Okay, so that is how we are just finding out the value here. Okay, so between 0 predicted and the output. Okay, so predicted and output, when we are just subtracting, you will get the -1, and this 0 -1 we are getting the -1, and 0 and this -1 we are getting the -1. Got it? So this is how we are just making it out, but here both are 0. So 0 minus 0, we are getting only 0 here. Okay, and the learning rate is 0.5, right? So this is how we are just updating the weight, okay, using the formula, right? Okay, so this is how the learning rate, which is also identified. Okay, zero point 0.5, how it came. So we can say that weight of old plus alpha. Okay, so that is, what is the value of alpha? Zero point 0.5. Okay, and D into Xi, that is -1 into 1. Okay, -1 into 1. Okay, we are getting the zero point 0.5, right? Okay. So this is for implementing the logic gates. Okay, for not, and, or, all, or, which is coming under SLP, right? Okay, so you know about not, whenever giving input, the negative of it will be treated as an output, and is like a it's like a multiplication. Okay, so 0 into 0, 0, 0 into 1 is 0, 1 into 0 is 0, 1 into 1 is 1. Okay, so that is how it is like a multiplication, and R is like an addition. Okay, so wherever we are giving the input, at least one it comes also, we will get the output as like this. Got it? So this is how we are just okay, implementing of the logic gates. Okay, so how we are doing it. Appropriate weights and thresholds we have to calculate in order to classify correctly the different classes. Okay, so when you just look at here, you can see between the and, or, okay, and then you can see here what is the input value and what is the output value. According to that, you are getting the output as well. And it's like a multiplication, as I told, right? 1 into 1 alone will come 1. Okay, but in the R, that is different. 0 into 0 alone, it will come as 0. Yeah, at least one input as 1 also, it will be reflected in the output as 1. Okay, so this is the OR gate, right? Okay, so when we are just drawing for and okay, so that is the time how we are going to make all these things are zeros and only class 2 which is coming under okay, both are positive, right? Okay, 1 1 and you are getting the output, right? So here when we are just checking it out, 1 comma 1, okay, both are at the peak, right? So we are getting the value as 1. All the remaining things which is coming under the linear line only, 1 comma 0 or 0 comma 1 or 0 comma 0, all are coming under the line, okay? So but when you consider here, you can see the weight W1 and W2 both are 1, okay? And then we are getting the pi as zero point 0.5, okay? So that is the time you can see all these things which are above the line, okay? All the things which are above the line, because you can see all the combination you are getting the output as 1, it is positive, right? Okay, so this is how we are just finding the decision boundaries, okay? So let us see the code directly now. Okay, so first we are going to import the numpy as np, okay, and then pandas as pd for numeric and the data frame, okay, and then we are going to scale and metrics, okay, performance metrics we are going to find out, that is accuracy, precision, recall, and f1 score. It all are very simple in this, just we can call the function name, right? Okay, so loading the data from csv file. Okay, so that CSV file, we are just loading it out and then assume the last column is the output. So automatically we have to find all the column, okay, which is not included with the target value, okay, except all that, all the columns we have to bring, and only here the target output, okay, which is also given, okay, only the last target column, okay, so that is how to denote. We are using only comma minus 1. If you want to denote everything, we have to use colon and minus 1. Okay, so that is how we are just assuming the last column is the output. So now for initializing it, we are just initializing, okay, the training count and n features, okay, all that thing we are just initializing, weights, learning rate that is given at, that is at zero point 0.1, and epochs, that is iterations, we are just giving at least iteration of 20, okay, so that is how we are going to do, that is the initialize parameters, okay. Now how to train the perceptron for each iteration, that is for epoch, in range epochs, okay, for datum in range, that is the training count, okay. So all the datas, okay, so that only we are just mentioned. So how we are going to calculate the output sum, we are finding the summation of np, okay, into multiply of x and weights, okay, so that is how we are just doing the output. And then activation function, how to do means, we have to find out the output value which is equal to 1 if output sum which is greater than equal to 0. Okay, if it is greater than equal to 0 means we have to consider as 1, right? Or otherwise we have to consider as 0. Okay, so this is how we are just finding out the activation function. As we saw in the PPT, we have seen activation function, either it will be 1 or it will be 0. Okay, according to that it will be mentioned, right? Okay. So next is compute the error. Okay, how we are going to compute the error? We are finding the y, that is the target column, right? Y of datum minus output value. Okay, so that you will get the error. Okay, so that is how we are just finding out the error, and how to update the weights. Okay, so that is the final thing we have seen, right? That is weight equal to weight plus learning rate. Okay, you will give the learning rate as an input into error. Okay, we are finding the error, right? Into x of uh, datum. Okay, so that is how we are just giving the updating the weights. Okay, we are just updating the weights, learning rate, which is the value like point 0.1 or something, it will be given. And then error we are finding out in the previous. Okay, and then we are finding the hex of datum. Okay, so that is the each and every column, right? That is other than the target column. Okay, target variable. So predicting the output for accuracy assessment. Okay, so how we are doing for datum in range, that is a training count is a thing we are just passing it out, and then we are giving output sum, which is equal to np dot sum of. Okay, so already we have found, right? Np dot multiply of x datum, okay, comma, colon, and then we are finding the giving the weights. Okay, so now we are finding out the y pred value. Okay, so y pred we are just appending into it, and if we are saying that if it is 1 means, if output, okay, sum which is greater than equal to 0, that means we are getting 1, else 0. Okay, if this condition fails, we can say that it is becoming 0, right? And now we can say that y pred, which is the numpy dot array. So array format, right? Array of y pred. Okay, we are going to get it out. Okay. So calculating the performance metric. What are the things we are going to calculate? Accuracy, precision, recall, and F1. Just we are just passing the function name y and y pred. With that, we can find the accuracy. Y pred, and zero division equal to 1. This is the assumption we have to give, okay, to show it is the okay, precision. And then we are just finding the recall for that y and y pred which is used. Okay, with that we can find out the recall. Okay, so all are okay, predefined function. Just we can call the function by giving f1, that is which is equal to f1 score. Okay, so we can just print. Okay, print the final weight, accuracy, precision, recall, and F1 score. Okay, so this is how we are getting the value out of it. Accuracy is almost 73%, precision is also 73%, and recall 1, and F1 square again, it is 84 percent, right? Okay, so this is how we can just doing the performance metrics as well. Okay, so I hope you understood the SLP. Okay, so with the code also. Okay, so let us see. Okay, how you are doing, and easily you can understand the concept and you can do the best. Okay, all the best, students. Thank you.